Hi guys, I did get a couple of questions on the worksheets, so I'm going to create a couple videos here to help you guys out. And I already did notice that on our review, there was at least one problem that was incorrect. So this will be the correct answer for it. And so feel free to, again, tell your friends so that they don't get confused. So before we start, I already wrote a couple of equations down here. I have the equation area of a equilateral triangle, and this is supposed to be an equilateral triangle. Let me make that nicer. All right, all sides are the same, is equal to um, s squared times root 3 over 4. We did not get that anywhere from just anywhere. We can derive it, and if you'd like me to do that, I can. Just let me know. I can make a video for that equation. But that's the area that we use for equilateral triangles. With that formula, right? One thing we have to understand is that a hexagon, a regular hexagon, is actually made up of six equilateral triangles. So that means all sides are the same. I have already drawn one here. I've already labeled the sides. I guess you can also say I labeled the equilateral triangles in the hexagon. So the way that we use this formula is we can actually just say that the area of a hexagon is six times the area of an equilateral triangle. So it's literally just that exact same formula, just multiplied by six, since this has six, one, two, three, four, five, six, right? This hexagon has six equilateral triangles. So let's go ahead and do a couple of things here. So for example, um, let's just do number one. Let's learn how to use this formula first. So my formula here obviously is just going to be s squared, so side squared times root 3 over 4. Since this is s, my area of this triangle is going to be 8 squared times root 3 over 4. So that gives me 64 root 3 over 4. 64 divided by 4 gives me 16. And remember, we can just keep that as 16 root 3. So let's leave it as perfect answers. So I'm just going to go ahead and say that this answer here is 16 root 3 inches squared. And that's it. All you got to do for that formula is just plug in the side length. Um, but what about when they don't give us the side lengths, right? In this case, because this is a triangle that we're talking about, equilateral triangle, we can just divide this not by 2, but by 3 here. And so your side length here is going to be 20. So I'm going to let you find that area yourselves. And I just went ahead and gave you your S variable. Now let's look at number 4. So again, side length, if they give it to you, it's much easier, but we have to kind of think about it a little bit when we're talking about the perimeter. And just in case, again, you're wondering, and I wasn't clear about why we're dividing this by 3, that's because we're talking about a triangle with 3 congruent sides. So we just divide 60 by 3, since this is the perimeter. Now, for the perimeter of a hexagon, well, if we have 6 congruent sides and all of them, we don't know any of them, we can just label one of these X. It doesn't matter which one, right? Because if it's X, well, I'm not going to say equals. Let's say that's X. We have 6 of them. We have 6 X's, right? One, 2, 3, 4, 5, 6 are all X's. So if I add them all up, I have 6 X's, and that perimeter is 54. So if I divide it by 6 on both sides, well, then I'm going to get 9. And that's my side length. My side length is 9. So maybe let's go, whatever. Let's just leave it as x equals 9. But remember, this is my side length. Side length is 9. Um, I don't want to say 3 is equal to 9, but you know what I mean, right? So let's go ahead and plug in my side length. If my side length is 9, then I'm going to go ahead and just take this formula and I'm going to duplicate it. And all we're going to do on our side here, let's make this a little smaller. What we're just going to do is we're going to replace um, the side length, the S, with 9. Now, again, that area, 9 squared root 3 divided by 4 is for one triangle. So since we have 6, we're going to multiply that by 6. And this is where the answer key went a little wrong. We had only found the area of one triangle. Um, So this could give us 6 times 81 root 3 over 4. I'm going to go ahead and plug that into the calculator to see if it gives me a reduced fraction, and it's not, it's already fully reduced. So now I'm just going to go ahead and take 81, and I'm going to turn this into a fraction, 6 over 1, and just multiply across. So 6 times 81, um, 6 times 81 gives me 486 root 3 over 4. And now I'm just going to try to divide that by 4 to see what I get. I get 121.5, but by hitting fraction, math frac on my calculator, I can have a reduced fraction of 243 root 3 over 2. And that's my answer. Oh, and this is going to be centimeters squared. Done. That's my answer right here. And again, the way that we do it is by finding the area of one equilateral triangle and multiplying it by 6. Since you know the side length here, you should be able to do that one as well. But I think the key had it incorrect. No, it did not. Yes, it did. So let me go ahead and do this, right? Um, on the key, what happened is that we solved it for an equilateral triangle, but we did not pay attention that it was asking for a regular hexagon. So I want to apologize for that. But let's go ahead and do that together. Um, okay, so for the side length here, and I'm just gonna set it up, and you can let's do it together. So area of a hexagon is equal to side length squared, so 10 squared root 3 over 4. But remember, a hexagon has 6 of these, so we do have to multiply it by 6. So the area would be 6 times 100 root 3 over 4. 100 root 3 over 4 can be simplified to 25 root 3, and then multiply 25 by 6, and we'll get 150. So my total area of this hexagon is 150 root 3. And this is inches squared. And remember, number 4 was 243 root 3 over 2 centimeters squared. And that's it, right? So when you have the side length, this becomes a pretty fast process. Um, but let's keep going. Given a regular dodecagon, and a dodecagon has 12 uh, sides, right? Find the following. Sum of interior angles, measure of each interior angle, sum of exterior angles, measure of each exterior angle, and what do you notice about the measures of the interior angles? So let's go ahead and actually let me take a look. I'm going to give you the formulas that you would use for this, and then you can go ahead and try this because I do want to spend more time doing some other stuff. So if my dodecagon is n equals 12, my formula here will be n minus 2 times 180. Now this is the sum, and you guys should have this on your formula sheet, and I'll give you guys another formula sheet tomorrow on paper. Each interior angle for this is going to be n minus 2 times 180 divided by n, right? Because if we're looking for just one, then then we would just take that total and divide it by n. And the reason this works is because this is a regular dodecagon. Now, for the sum of the exterior angles of a dodecagon, for any actually, is always just going to be 360, period. Just 360 degrees. So this answer should be 360. And the measures for each exterior angle is just going to be 360 divided by m. So you'll divide that by 12 and you'll get your answer. And the one thing, and I want you to go ahead and answer E yourself. Okay, so let's keep going around here. Um, so I think I want to go through 8 doesn't seem that bad. You can find this height since this is the only thing that's 5. Right, this is 5. You can find the height using the Pythagorean theorem and get this height. So I'm going to let you guys do that. And then you have to use the Pythagorean theorem again to find this base. You do have to do it twice. I really want to go over maybe 7 because it's got special triangles in it. Um, so when we look here, we need to find the height. So this height here, we need to find. I know that's my height because it's touching my two bases at a 90-degree angle. Um, and it gives us a 60-degree angle there. So knowing that this is a 90-degree angle, this has to be a 30, 60, 90, which means that now we can use our 30, 60, 90, a root 3, and 2a ratios to solve. So in this case, they gave us our hypotenuse, which is our cos our 90, and that's 10. So it isn't super bad because we can go ahead and just set 2a equal to 10, therefore a has to be 5. So this is 5, this is 5 root 3, which means we found my height. My height is indeed, it's across my 60 degrees, so my height is 5 root 3. Now that I have that, I'm able to go ahead and just multiply base times height. 5 root 3 times 11. Remember that the radical kind of works almost like like an x, right? I have 5 root 3s, so if I multiply that by 11, well, now I'm going to have 55 root 3s. And this is in feet squared, and we're done. Right? Not too bad. Let's go ahead and do number 10. And that's the last one I'm going to do on this video. And if you have any other ones, you can go ahead and email me. I'll make another video tomorrow. Um, okay, so find the number of sides of a regular polygon if each angle is 156. Now, there's two ways of doing this. I don't necessarily like to teach multiple. I mean, I do love teaching multiple ways, but when there is no clear um, better one. I don't like for you guys to have to remember more properties than you have to. So the way that I like to solve for these is that n minus 2 times 180. And actually, I'm going to write 180 in front just because it's going to make our lives a little easier and so you can see what's happening. But remember that this is the same thing as this. It's just written differently, right? That's the 180s in the front. But I know it helps some students see it. Um, You know what? Let's not change anything right now. Let's go ahead and just leave it as usual. Um, because again, I don't want to change things and make you guys think, do double takes of stuff. So remember that this formula that's right here, the one that I wrote, n minus 2 times 180 divided by n, gives us the interior angle, just one interior angle of a regular polygon. So if my interior angle measure of one interior polygon is 156, we can just set this to equal to 156. From here, remember, I don't like this divided by n, so the only way for me to get rid of it is to multiply by n. So now I have n minus 2 times 180, and that equals 156n. Well, just because this constant, this 180 is on the right side of my parentheses, doesn't mean it acts any differently than if it were to be over here, right? We can still distribute this into both of these terms. So if I do 180 times n, I have 180n. If I do 180 times negative 2, I get negative 360. And now I have 156. And now the common mistake that students make is that they forget to write the n on this. If you do, you will get an incorrect answer. I know that it seems like it might be wrong by subtracting 180 here because we end up getting a negative answer on the left side, being, I believe it should be negative 24. Yep, right? But when we divide by this negative, we actually end up getting a positive. We end up getting 15 sides. So my answer here is 15 sides for number. Great. Awesome. Okay. So again, if you guys have any other questions, feel free to reach out. No problems going over a few more problems, but this I don't want our videos to get too long. Um, oh, actually, this is a good one right here. I'll do one more. This video is getting a little longer, but that's okay. Especially because this kind of confuses students because the answer is not uh it's not a positive one, or it's not none of that. It's not an actual number, it's an equation. So here my area of this trapezoid is 12x minus 4. I know that's weird, right? It's an equation, it's not a number. If one base is 2x and the other and then the height is 4 inches, can we find the other base? Well, yeah. Um, remember that the area of a trapezoid, area of a trap, what does it have? Is equal to my base 1 plus base 2 divided by 2 times my height. Well, they gave me my area. My area was 12x minus 4. They gave me one of my bases. My bases is 2x. Let's like base 2 as b. And then they gave me my height. My height is 4. So, okay, this looks a little odd, right? Now one thing that we have to, and actually, let's just go ahead and just take this a step at a time. I know that if I divide this by 1, I can go ahead and multiply this top by 4. And we're going to have to distribute. So let's go ahead and do that first, just to get rid of that 4. We can rewrite it like this, and some of you could see that what ends up happening is that we can divide 4 by 2 before we can do anything. And if you'd like to do that, that's perfectly fine. I'm just going to take the longer side since I feel like that's a little bit more intuitive for some students. So I'm going to go ahead and distribute here. And I get 12x on still on the left side, I get 8x plus 4b divided by 2. And now I can just go ahead and divide by 2, right? 8 and 4 are even numbers, so dividing by 2 is pretty simple. It's just 4x plus 2b. And remember, we're looking for the base, so this is what I want by itself. So let's start getting rid of everything else. I'm going to go ahead and subtract 4x from both sides. I'm going to go up here and finish this up. 8x minus 4 is equal to 2b, or not to be. Sorry, that was a bad joke. And now I'm going to go ahead and just divide both sides by 2. Remember that this left side is the full side, so you can't just divide 8 or negative 4 by 2. You have to do both. And my answer ends up being 4x minus 2, and that's equal to b, and we're all done. And again, it's equal to b, not to b. So my answer here should be 4x minus 2, and that is going to be in inches. So let me go ahead and move that over just a little bit, just so I can write inches here. Awesome. All right, so now go ahead and try everything that you possibly, I'll try everything that you can. I'm gonna make another video for the next worksheet since this one became a little long. I'll see you guys tomorrow.